In previous lessons, I taught you about the basics of creating objects in JavaScript. Now let's move on to some more advanced topics. As we go through this lesson, listen for some of these key words: encapsulation, inheritance, polymorphism, and overriding. These are concepts that apply not only to JavaScript, but also to any object-oriented programming language. Okay, the first topic I'd like to teach you about is the fact that classes have three parts. Down here we have a class of type account that we've invented, and it has a name, it has attributes, and it has a method. So basically every class potentially has these three different things. Truthfully, you could get by without including attributes or without including methods. You at least have to have a name, but generally speaking, you're going to have these three parts every single time. And there's a higher level way that we could think about this. As a new programmer, if you are a new programmer, then you might think purely in terms of code like this, but advanced programmers oftentimes think in terms of the blueprinting language for object-oriented programming, which is unified modeling language. And specifically, there's a type of diagramming called class diagrams, and this is an example of a class diagram. So think about the three parts that I just told you about of a class. Here's a diagram for it, and at the top of this you have a class name, and then in here you have the attributes, and in here you have the methods. If I were to turn that into a real example based on my previous code sample, it might look like this. Here's the name of the class, here are some attributes, and I haven't yet included methods, but that will show up in a little while. All right, just in case you are doubting me at this point about whether or not class diagrams written this way using the UML modeling language, if this is important, go out to Google and type in class diagram and just take a few moments to see how many results come back, and then look at some of the pictures that are representative of what you might find out there. So I'll just pause for a moment. Okay. Now that you've got a little bit of experience with the idea of using a diagram to represent a class, I'd like you to see if you could challenge yourself with a little test here. Take a donut and try to create a class from it using the diagramming technique that you just learned. And also think of a customer and try and create a class diagram for that as well. So again, start off with the name in the top of the three rows of the box. In the middle portion, put in any attributes, and you don't have to do any methods for now. Okay, if you go through that exercise, you might get something like this. You have a donut that has a string of the name of the donut, float for its price, and I for calories. For customer, here's a lot of basic things that are all strings. Anyway, this was good practice for thinking about classes. We'll be making these with JavaScript shortly. Okay, let's talk about methods now. So we were just talking about attributes. Let's focus on methods a little bit. And to introduce the topic of methods, I'd like to have us write up some code related to withdrawing money from a bank account. So here's a bank account represented. It has an attribute, which is the balance that is contained in that bank account. And let's work through a problem that could occur if you extract money from a bank account. Okay, first off, find yourself your Visual Studio Code editor and open up a folder, create a file. I will call mine objects.html. I will do the exclamation point to stub out an HTML document. I hit return, and everything's nicely filled out. I'm going to close this for just a moment. Down here in the body, I will add a script tag, and let's go ahead and start creating an account. So I'll type class account, and I'm going to give it some attributes. I'll give it an account number. I'm going to give it an account owner, and I will give it an account balance. And I could put in a constructor here, but just because I want to save some time coding, I won't do that at this time. So let's go ahead and create an instance of that class or an object. I'll say let O my account equals new account. And remember, in any programming language that you're looking at, if you see the word new, that's a pretty good signal to you that you're working with a class and you're creating an instance of a class whenever you see that keyword new. All right, so continuing on, let's go ahead and set the attributes here, myCount.iCountNumber, and I'll have this equal to just some random set of numbers that I'm punching in on the keyboard. And then I will set the account owner and a consultant that I know who recently graduated from our university. Her name is Ching Tong, so we'll make her the star of this video, and I'll say that the account balance is $15, although in reality I'm sure that as a highly paid consultant that her account balance is much higher than that. Okay, now let's move forward to the problem I wanted to talk about. So I'll say let's withdraw some cash. So I'll say myCount.f account balance equals, and there are some shortcuts I could do, but I won't use those. I'll just say I want the new balance to be the current balance minus 15. And now I'll say let's check our balance. All right, so I'll do an alert statement. All right, so let me go ahead and hit save, and then I want to run this code. So I'll right click on this using the live server plugin that I've installed earlier, using that icon down there. I open this up, and I'm going to bring this window over here, and it says 0. All right, well, first of all, that doesn't sound right at all. Count balance. Oh, because I should have subtracted more than that. I guess that did make sense. Okay, let's try and overdraw the account then. So that would be fine if you emptied out everything, but what if you took out more than what's supposed to be there? Then you see this, minus $35 is the balance of your account. Now, if you are the owner of a bank, this should never happen. Okay, so let's go ahead and make a little statement here. I'll say, oh my heck. As a bank, this should never happen. Okay, yeah, you should be terrified if your customers can take out more money than they actually have, because then your bank's going to be soon out of business. So let's go ahead and fix that and make it so that can't happen. I'm going to go back up to my template for my objects, or in other words to my class code, and I'm going to add a method here that's going to control access to this variable. I'm going to call this method withdraw cash, and I'm going to need to pass in the amount that's going to be withdrawn, and so I will say f amount to withdraw. And notice that, like the variables or the attributes that don't have anything that precedes them, like let, a function or a method that is part of an object or a class is not preceded by something like the word function. So just kind of a unique feature of using classes. You just write it out like you would usually use it. Okay, so what should we do? Well, we can do the normal math on this. I'm going to refer to the internal attribute of this object, so I refer to it with the keyword this dot f account balance, and I'll use a little shortcut this time. I'll say minus equal to, and then I'll say f amount to withdraw. Okay, so that if I pass in 50 to this, it will do the subtraction, but I said that I wanted to create some protections around this data so that we don't break our rules, or at least the intuition that we shouldn't be able to take out more than we have. So I'm going to surround this by an if statement. I'll say if f amount to withdraw is greater than what we currently have, this dot f account balance, let us do a little statement here that says alert, you don't have sufficient funds. But if they do have sufficient funds, let's go ahead and print that out. All right. So we have set up this function that is, or this method that's going to allow us to modify this and put some protections around it. Let's go down and use it now. So I'm going to get rid of that alert statement, and instead I'm going to withdraw some money. I will say, oh, my account dot withdraw cash, and let's see if I can take out $50. I need to comment this out so it doesn't happen prematurely. All right, so now I've simply set the attribute, and now I'm going to try to subtract some money, and then I'm going to do an alert statement to see how much money is in there. All right, let's watch what happens. I'll hit save. It says you don't have sufficient funds, therefore it doesn't take any out, and so we still have $15. Okay, what if we tried to take out something a little bit more reasonable, like $10? All right, I'm going to go ahead and hit save. And I didn't get the error message. It subtracted the right amount of money, and then after that method was run, we do our alert statement, which told us that we had $5 left. Okay, let's go back to the conceptual content. So what we did is we went from this code over here on the left-hand side, which is pretty bad because we could overdraw our account, to what we have over here, which is a way to protect this particular variable. And if I go back to my class diagram that I had before, I can update that as well. So originally I had my account class with its attributes, and now I have included a method. So methods always go in the third row of your class diagrams. And notably, this is a nicer way to discuss the content of your code, because a class diagram usually has just some brief representation of what's contained in there, whereas if you're looking at the raw code, you could be looking at thousands and thousands of lines of code. Okay, I put a little sign over here that says private, no unauthorized access. So the reason why I put that warning sign there is because we've just discovered something, that sometimes when we're accessing our variables like account balance, that they need some protection because a programmer or a customer could inadvertently do something that should not be done. And that brings us to the idea of encapsulation. And encapsulation is the idea that your data and access to it, whether it's setting that data or reading from that data, can be protected by using methods like the one we have below. Now, formally, here's a definition that I would create. I would say my definition of encapsulation is this idea that access to variables of an object can only be allowed through methods, and this helps you protect the integrity of the variables. And Wikipedia has another way of describing that. It says it's bundling of data with the methods that operate on that data, or restricting of direct access to some of the object's components. All right, so moving forward and talking more about this idea of encapsulation, what I've done here is I've taken my class account and I've protected another variable. This time I've protected the variable account owner. I've made it so that if I want to find out who the account owner is, that one of my options is to call the method getAccountOwner, and it will return that value. Sometimes, in other cases, I might do something special to this, like maybe turn it to uppercase or something else before I return it. So it doesn't have to be just simply returning the raw value. I call this a getter. And down here, I have an example of a setter for a particular attribute or variable of my object. In this setter, It takes an argument, which is an account owner, or the name that we want to assign to that variable. And it does a little bit of checking, and it says, let's make sure that what I just passed in is not empty, and also that what I just passed in is of type string. It doesn't really make sense to, as a person's name, assign a number in here. So if both of those things pass, then we're going to go ahead and make that assignment. And having done these methods over here, I can come over here to my account class in its diagram and add a couple more methods. So this is the getter method and this is the setter method. So now we've created encapsulation as it relates to that particular variable. We could expand on this idea, and for every single variable that's part of our class, we could create a getter and setter for each one. I didn't update the code for that, but you can imagine that the code gets a little bit longer as we start coding out all of these things. Nevertheless, getters and setters are an important concept and relate to this idea of encapsulation.